Welcome everybody. Good afternoon or good morning, depending on where you are connecting from. My name is Stefano Battilossi, University Carlos III Madrid, and I'm very pleased to host this new installment of the International Macrohistory Online seminar. Today, the speaker is Conrad Copeland, who will be presenting a paper on riding the monsoon, geography, and Iron Age trade in the Indian Ocean. Conrad is an international macroeconomist with a special interest. One of his special interests is in the geography of trade, both present and past. He has a PhD in economics from the University of Bristol. He is currently a research fellow at UCL, University College of London, and his main work is Deputy Director for Investment Performance and Analysis at the Department for International Trade. Before I give the floor to Conrad, let me just remind you the rules of engagement. We will be listening to Conrad for 40 minutes. If you have clarification questions during his presentation, please put the question in the Q&A, and I will briefly interrupt Conrad so that he can answer. You can also write down in the Q&A your questions for the final part of the seminar, and then I will pass them on to Conrad in the last 20 minutes of our seminar. And as usual, there will be an extra 15 minutes after the end of the first hour for a more informal discussion with Conrad. So I think that's it from my end. So without any further delay, Conrad, the floor is yours.
Great, thank you very much. I'll just share my slides. There, can everyone see that? Excellent.
Yes.
Great. So, as said, I'm Conrad Copeland, and this paper is called Riding the Monsoon, Geography and Iron Age Trade in the Indian Ocean. And I can advance the slides. We'll start with a bit of an introduction. So the principal motivation for this paper comes out of the recent debate about the extent and connectedness of ancient trade networks. So trade in the ancient world was hindered by very high trade costs and technological limitations. Ships, were only so seaworthy, pack animals were only so fast. And so this reduced the gains from long distance trade. In gravity terms, the effective distance was nonlinear. And in some cases, it's argued that it was highly asymptotic, creating an effective upper limit on how far away a network could reach. So this creates an interesting question of why there was such a robust intercontinental trade network in the Indian Ocean, with the answer usually being the geography and climate of the region. So land masses around the Indian Ocean are arrayed in sort of a large horseshoe, and the monsoon winds are regular, predictable, and reliable. So this combines to create a situation where a vessel could leave a port on one side of the Indian Ocean, and provided they left at the right time of year, would almost certainly reach the other side, the usual hazards of sea voyages notwithstanding. So this paper explores this effect and the impact that it had on trade networks in the region. So what does this paper actually do? Well, I compile trade data from never before used textual sources and calculate wind-dependent transportation costs. I then model Indian Ocean trade network with a modified Ricardian gravity model, and use these results to estimate the relationship that this trade network had on development in the region. And a bit of the preview of the main results. So first, wind-dependent speed costs matter for the network, but these effects are actually highly nonlinear. So this means that the trade system of the Indian Ocean in the Iron Age is well defined and well structured. But this result is key for the further results in the paper, as it allows trade to be a key economic determinant of outcomes. Second, diversity of exports is linked to higher levels of development, while imports are the reverse. So this is the first of the two core development outcomes of the paper, and implies the presence of export-led growth in the economies of the cities of the Indian Ocean littoral. The third result expands on this point. There is some evidence for an ancient version of the resource curse. Cities that were reliant on cash crops like spices and incense, which tended to have more plantation-oriented and centralized production patterns, were underdeveloped, operating in a similar way to oil today. So this paper builds on a lot of recent work on ancient textual trade data and the discussion around the best way to model ancient trade costs. Baramovich sits on the more traditional gravity side, while work like that of Bakker sits on the hard upper limit side of ancient trade. This paper, as a bit of a spoiler, tacks more towards the traditional gravity side. But it also builds on important developments in ancient trade data and the discussion around how economically sophisticated ancient economic connections were. Temen's work is probably best known for this, particularly in the debate on whether the domestic Roman economy operated as a complete market. And this is similar to the argument that I make in this paper regarding the functionality of the trade system in the Indian Ocean. So for the rest of the talk, I'll cover first the data used and then move on to the estimation strategy, followed by results and for ancient trade. And then we'll talk a bit more about the results for the ancient development levels, followed by a brief conclusion. So let's start with the data. So trade data comes from the periplus of the Erythraean, there we go, we moved on finally. It comes from the periplus of the Erythraean Sea. It's a mid-first century document written by a Greek-speaking merchant. Its narrative follows a roughly circular path around the coasts of the Indian Ocean, identifying cities, the goods they trade, and the places they trade with. So at the time, a periplus was generally just a record of someone's travels. In Greek, I think it literally means to journey around or something like that. People tended to write them as a testament to their exploits and adventures, and they tended to highlight things they did or saw and the peoples that they encountered. The periplus of the Erythraean Sea is somewhat different and unique because it reads more like a trade manual for merchants. It itemizes goods, ports, anchorages, trade goods, and that could be bought and sold in cities and locations, and includes much more detailed description of economic and nautical matters than cultural or political ones. It also somewhat uniquely avoids clear embellishment and fantastical observations, which are common in other works for descriptions of foreign cultures and animals. This tends to give it a fair amount of credibility among classicists and scholars of ancient literature. But the key part for us is the discussion on trade. And so importantly, it includes a whole range of data, including 150 individual products and 47 identified cities. But it does come with some data issues, and the descriptions of products in the periplus come in three varieties. The first variety of record is goods listed with a partner city identified. These are easy to these are easy to use rather, and as they comes with a city dyad and a product, and so it's direct. The two clear examples of this type of record are in the excerpts. In the top one, we can see an example of tunics and cloaks being exported from Arsinoe to Malau. And in the bottom one, we can see copper, sandalwood, and teakwood exported from Berigaza to Omana. And the second variety of record is goods that are listed with a partner region rather than a partner city. So Arabia instead of Musa, for instance. And there are clear examples of this in the top excerpt, with myrrh, frankincense, and copal being exported from Avelites in Malau to Arabia, more generally, with no importing city identified. In these cases, it's still possible to interpolate the data relatively cleanly. And so I took every city in the identified partner region that exported or imported the given good, as the case may be, and identified it as a partner city. So essentially, if city A exports product X to a region, all the cities in that region that import X are counted as trade partners with city A. The third case is even less specific, where it merely identifies goods that are imported or exported by the city with no indication of where those products go. So while this is less helpful for gravity estimation, it's still useful for the development analysis in determining overall export and import baskets. And so I use it there. Linked to this are issues of data quality. So traditional gravity models use value or volume generally of goods traded. The Periplus, unfortunately, is not particularly helpful with this. It does include indications of value and quantity, but they're very vague and relative. Words like not much or inferior or the best, or descriptions of so much of a product that it requires larger ships. And so ultimately, these are very subjective and not helpful for gravity estimation. So this analysis disregards these terms and exploits a feature of the Ricardian model by using the variety of products traded rather than the value of trade. On this slide, I show the export baskets of cities grouped by region. This chart illustrates very clearly an effect that we'll go into a little later with the nonlinearity discussion, and that's the regional clustering of goods. So cities in the same region, they appear to have similar export baskets, hinting at endowment effects in the data. You can see that export baskets from cities in East Africa are dominated by ivory and shell products. Persia exports a lot of wine, and India is dominated by textiles, glass, and gems. Right, so I mentioned that the analysis uses the variety of products instead of volume or value. And this is captured by a count of the number of different products traded between cities, which is XIJ on the slide. Importantly, this is the specific product level, not product group levels. And so it is essentially a measure of the total number of different and differentiated products that are traded. The variable for the development analysis is slightly different, and it uses a modified Herfindahl index that measures how diverse the offer basket of a city is with the corresponding with a corresponding index for imports. This index is calculated using product categories, not individual products. So there's the key difference. The total value then is given as a sum of the squares of product category shares in a given city, and it's subtracted from 1 to make the ordering of the index a little more intuitive so that higher values are more diverse. For transportation costs, I looked to construct accurate wind speed, augmented sailing times between the various cities mentioned in Periplus. And so because of the seasonal nature of navigation across the Indian Ocean, I take data on wind speeds during both the monsoon seasons. The data come from daily averages between 1992 and 1995 for the heights of the summer monsoon and the winter monsoon. In order to calculate sailing speeds in these winds, I needed information on how quickly an ancient ship travels with the wind. This is more difficult than expected. There's actually very little information on this in a generalizable sense. The only existing sea trials with Roman-style sailing ships are with river ships in Western Europe, which is not suitable for the conditions of oceanic sailing. So to address this, I used speed data for the sea trials of the Nanawa Maru, which is a reconstructed merchant vessel from the Edo period in Japan. So while it's outside my time period and region, it is very similar in design to the types of cargo ships that would ply the Indian Ocean and provided very consistent data. So you can see the wind speed chart published in Nomoto, Masuyama, and Sakurai at the bottom of this slide. This allowed me to create a function that could calculate a ship's speed for any given wind speed and angle. I can then input this into a mesh of all possible routes overlaid on the Indian Ocean to get speeds for each line segment. So this then allowed me to calculate the fastest routes between every city identified in the Periplus, both in the winter and summer monsoons, though only the summer is shown on this slide. The shape of the routes on this map illustrate basically the benefits of sailing with the monsoon winds. Most of the routes follow a bit of a horseshoe shape in order to maximize wind speed benefit rather than sort of straight lines just across the ocean. So ultimately, that's great. There's lots of data, fancy calculations, but the important part is this at all accurate? And the answer is, well, yes, actually, very much so. This table shows a comparison of the travel time between various cities as calculated using my data and the time attested in ancient sources. As you can see, it's actually fairly on point, give or take a day or two. Particularly the trip from Egypt to India, which would have gained the most from the wind effect. It comes in at just over 64 days, which fits very well with the times given for leaving Myos Hormos and arriving at Beri Gaza. Now, for the estimations in the gravity model, the distance between two cities is calculated as the time it takes to make a return trip when sailing in the correct seasons for the direction of travel. So now for the historical development part, I use the tried and tested method of creating a grid space of 0.5 by 0.5 degrees. And I then restrict the sample of those grid cells to those within 500 kilometers of a city, as you can see in the map. This gives a radius of influence, or sort of a hinterland area for each of the cities in the Periplus. And granted, this is a fairly large area, but it's taken as an upper limit on the influence of cities. And there are some robustness checks later on that reduce this distance considerably. I then use archaeological data from the Pleiades data set to proxy for development levels. This data set's a compilation of all sorts of geographical features and elements, all the way from before the Bronze Age to the late medieval period. But I just take the human constructed parts, settlements, buildings, and other structures, and only those active during the period of the Periplus. So this restricts the data to about 6,600 sites of the right type in the right range. It's shown by orange crosses on the map there. So I use this data to construct a growth measure that is sort of analogous to night lights data from modern development work. The sites serve as a proxy for human activity, and the more concentration of human activity equates to higher levels of income or development. There is scope to weight this data by the type of structure, since the data includes a variety of different types, but I chose not to pursue this because it would require the assignment of development values to different site types based purely on conjecture. There's no sort of systematic way to assign development levels to different types of sites, whether it's a well or a building or that sort of thing. The actual growth variable that I use is the number of sites in a grid cell before and after the cutoff date. The cutoff date is given by 30 BCE. This is the date that Rome took control of Egypt and had direct access to the Indian Ocean, and therefore was the effective start date of the trade system described in the Periplus. The maximum date used is 640 CE. This is when the Arabs conquered Egypt and effectively excluded Rome from direct access to the system again, ending the system as it was described in the Periplus. So the growth measure is therefore the number of sites active between 30 BCE and 640 CE minus those active at 30 BCE. This table gives a summary of site distribution by region. One issue with the data is the relative abundance of sites around the Mediterranean. Now, there's two likely reasons for this. The first is that archaeologists have been more interested in the Mediterranean historically, so there are more excavations and therefore more data. The second reason is also that these areas were actually more likely to be part of the Roman Empire for much of the time period, and therefore benefited from direct government infrastructure money that is exogenous to trade considerations because of the centralization and militarization of the Roman administration and infrastructure planning. Fortunately, these two factors overlap and can be controlled for by accommodating whether the grid cell was a part of the Roman Empire or not. And so I include this control in all of the development estimations. So now we go on to the gravity estimation methodology. So essentially, I build on the model of Eaton and Kortum to set up a Ricardian gravity model where more competitive cities will trade more varieties, not just more goods. Baramovich sets up a similar model in their paper. In the interest of time, I'm going to skip sort of the actual derivation of it, since it's in the paper, and a more detailed and possibly better version are in Eaton and Kortum itself. The setup is that cities produce goods based on a randomly drawn technology parameter combined with other input costs, mostly labor in a pre-modern economy. And cities choose to import goods based on price and will import from the cheapest source. The price distributions that cities face are based on a function of the production technology, input costs, but also transportation costs. Competitiveness is therefore based on the costs associated with these factors. Larger cities will have lower labor costs due to labor abundance, and cities that are closer together will have lower transportation costs between them. More competitive cities will therefore have a higher proportion of the cheapest offer baskets, and therefore will export more varieties of goods to a given city, as well as more goods overall. And this is the fundamental feature of the Ricardian model in this case, because more competitive cities will trade more varieties. And that's the piece that I exploit. Ultimately, this model produces a functional form in line with traditional gravity models, and therefore can be estimated in an identical way. Important for this is the varieties feature of the model, which I keep stressing, but it's true. Since the data does not contain reliable volumes or values, we can only measure the number of varieties traded between cities. The fact that this gravity model accommodates the number of varieties allows it to be fit to the data, whereas a more traditional monopolistically competitive gravity model would not be able to. The estimation equation here is a standard gravity estimation equation with the two mu terms accommodating city fixed effects. All of these estimations use PPML so that zeros can be included, which is an important feature for the nonlinearity a little later. So the gravity results ultimately show that distance matters in the network and that the network is well modeled by a gravity equation. As mentioned, the variable sail dist is a wind speed calculated distance of a return trip between cities. Now, the coefficient in the first column is fairly low, but it does still sit within the accepted bounds of gravity estimations. But more importantly, the first column only includes attested trade. So as I mentioned with the data, there are 47 cities identified in the Periplus, but not every city is paired with every other city, either directly or through regional interpolation. So this leaves a lot of missing city pairs that are not included in the data. And to explore this a little further, I included the data for non-attested trade as zeros in the second column. Essentially, any of these missing city pairs with no mention of trade in the Periplus was recorded as having zero trade. Including these zeros removes the significance of the linear coefficient by itself, but it reveals a nonlinear specification, which is shown in the third column, potentially explaining the initial low coefficient for the restricted linear model. So the functional form shown in the third column shows that the relationship takes a bit of an inverted U shape. And if we graph this, we can see this U shape and verify that cities that are very close together and very distant both tend to trade less. The most interesting part of this, I think, is that there are a lot of zeros and low values that bend the distribution at the low end. And this implies that something is going on between cities that are very close together. It could be related to one of two or both effects. First, that the merchant who wrote the Periplus just wasn't that interested in trade between cities that are close together. Near trade would likely tend to be low value staples, and international merchants would be more keen for higher value or luxury goods. And so he may have just omitted it. The likelihood of this being the primary or principal answer is reduced, I think, by the fact that many of the goods mentioned in the Periplus are, in fact, these low-value staples, such as fish, grain, and other low-value commodities. The second possibility is that the missing trade really isn't there due to an endowment effect. Cities with similar export baskets could be less likely to trade with each other, or at least trade fewer products. And so it could actually be true zeros rather than omitted. This being a pre-industrial world, export baskets would be heavily influenced by natural resource endowments, which would tend to be more similar with geographic proximity due to climate and environment. So to explore this, I build two measures, one for proximity and one for endowments. The proximity measure is just whether or not the cities are within a 14-day sail. This is something that could easily be covered several times in a single season and is less dependent on sort of monsoon wind effects. This proxies for the ability for routine and small-scale trips to occur between these cities, and the type of trade, the type of trade that would involve more common staples and lower value goods on sort of a quotidian basis, more useful in local markets than international markets. The endowment measure is an index of similarity across export baskets, with higher values indicating more similar baskets. The results seem to indicate that it actually could be a combination of both, really. With the simple proximity effect staying significant and fairly large with the inclusion of endowments. But there are two important things here. First, the coefficient on distance is much more in line with what we would expect in a gravity model, indicating that this goes a fair bit of the way to accommodating the nonlinearity, pinning down the anomalies of the functional form of the trade in the Indian Ocean in this period. Second, the endowment effect is large and significant, indicating that there is likely a strong endowment effect in addition to more traditional Ricardian trade effects. This means that a city's resource endowment is potentially another source of comparative advantage for a city, adding elements akin to a Heckscher-Ohlin model to the Ricardian framework already established. So now that we have a model of the trade network, we'll move on to the development effects of it. And so I build three measures to help get to the bottom of how trade impacted development. The first is a simple distance measure, i.e., did being close to a city in the Periplus contribute to development? That's sort of a pure hinterland effect. The second uses the Herfindahl-Stahl measures of export and import dependence with the indices for export and import diversity mentioned previously. This captures the effect of diverse export baskets and diverse import baskets on development to model sort of the potential export-driven development effect. It's sort of an ancient industrial policy. The idea is that areas with more varied exports will fuel their development and urbanization with the Iron Age equivalent of positive trade balances. Conversely, cities that are very dependent on imports of many products to sustain their standard of living are less likely to generate diverse and robust local economies, and so that could potentially stagnate. This measure is distance weighted in the estimation equation in order to accommodate the fact that the influence of cities will diminish as you move deeper into their hinterlands. The third measure gets at the issue of the resource curse and uses the share of specific sectors in the export or import basket of cities. The estimation looks at manufactures and artisanal goods, more cash crop goods like spices and incense or plantation products, and finally, the import concentration of bullion and precious metals, all weighted again by distance. So this borrows from the resource curse literature by arguing that economies based on the export of highly lucrative raw materials are more likely to generate weaker institutions and misappropriate the gains from trade away from development activities. In this context, spice and aromatics, such as incense, fill the role analogous to oil in more modern economies. In this period, spices and aromatics were generally low cost to produce in their raw form, and mass production lent itself to plantation-style cultivation. This created a system where it was very easily centralizable and manageable by local rulers and their agents, and it often was set up in that way. Creating essentially the perfect environment for high profits, particularly when traded to Romans who had an insatiable thirst for these products, and the potential for concentrated enrichment rather than more diffuse profits to multiple suppliers. The last element relating to specie and bullion is to explore Pliny's famous complaint that the cities of India were getting rich on Roman coin exports. They complained about 100 million sesterces per year. And whether this did in fact fuel development of cities mentioned in the Periplus. And so to explain somewhat in context, Roman merchants tended to trade hard currency for hard currency and bullion and sort of raw metals for products from the Indian Ocean, partly because there were not many products from Rome that Rome produced that were in high demand in the region, and those that were tended to be light in weight, bulky in volume, neither of which is really ideal for transoceanic trade voyages. Coin and bullion were heavier, more compact, and more efficient to trade for many of the goods that Roman merchants wanted. And naturally, because humans are the same all over and across all times, this led to several debates, complaints, and arguments among Roman political class about the wealth of Rome being sent overseas to pay for so-called frivolities and products that alleged true Romans would never need. Most famous among these was Pliny the Elder, who complained that cities in the East, as mentioned, were being made rich and prosperous on the money that Rome was giving them, the 100 million sesterces per year. Just for conversion context, I guess, skilled laborers in the first century in the Roman Empire tended to receive around 2 to 3 sesterces per day. So just to give you an idea of sort of the magnitude of the sum that Pliny was complaining about. So for the results, we get some interesting effects. First, there is a clear distance effect, which is in line with what we would expect and justifies the use of distance weights in the other estimations. The second is that there is some evidence for export-led growth being effective. Cities with higher export diversity tended to be more developed, while cities with higher import diversity tended to be less developed. Contributing to the idea that the network and the ability of cities to be prominent export centers of the network contributed to the prosperity of those cities. Then we come to the product-specific elements. Cities that were more dependent on manufactured exports tended to be more developed, while cities that were highly dependent on bulk export of cash crops were underdeveloped. This gives some evidence for a similar effect to the modern resource curse. Cities that were dependent on products that encouraged weaker institutions, such as cash crops like spice and incense and aromatics, with the city leadership or wealthy individuals controlling production in a more centralized way, ended up having their growth stunted, with this potentially leading to more chronic underdevelopment of their cities and hinterlands. And finally, we have the effect on bullion, which we can see that perhaps Pliny was right to some extent. The export of large amounts of specie from Rome does seem to be related to higher levels of development. Now, there are several possible explanations for this, all of which fall outside the scope of this paper, but there are two that I think are most interesting. And the first is the tendency of Rome to pay for high-value goods with coin instead of reciprocal goods may have concentrated wealth in the hands of a local oligarchy, which then may have spent the money on building projects and public works to sort of build infrastructure and develop their cities, fostering growth and development through that. The large elasticity of the result would imply, though, that there would be a implausibly large effect for public infrastructure alone in this. And so the second potential reason is that the large influx of silver, because most of the Roman currency that was exported was silver, eased liquidity constraints in Indian Ocean economies, where silver was relatively scarce, and contributing monetary stimulus to cities and economies that supported growth. The relatively high value of precious metal content in Roman coins compared to local currency, combined with the regularity of restamped and locally reissued Roman coins being found in archaeological digs in India, supports this possibility. One further piece of historical evidence to support this is the attested extensive use of coin blanks by merchants from Rome as a trade commodity, rather than actual minted coins, supposedly making it easier to restamp them for local use. This brings us to some robustness checks of the main results. And so I test the robustness of the results in three key areas. The first is the calculation of trade flows. The baseline estimation takes trade as measured by a count of total product varieties traded between cities. In this case, I calculate trade as the share of total products produced by the cities that are traded between them. This gets at a more subtle feature of trade in varieties of goods and reduces the bias of cities that have smaller production baskets due to endowment effects. The second aspect is the cutoff date for the development estimations. I originally used 640 CE as the cutoff, as this was when Roman direct influence on the Indian Ocean trade system was effectively severed. But there is a historical argument that there was a serious decline in Roman involvement and international trade more generally over the course of the 3rd century. This happened for a host of reasons, including internal turmoil and the difficulties that the administration was having at the time. And so the argument is that this is perhaps a more suitable end date. To accommodate this, I adjust the cutoff date to 300 CE, which is the latest date at which this 3rd century decline would be complete, as an alternative end for the development effects. And finally, I adjust the size of the hinterlands in the sample grid space around cities, since 500 kilometers could be considered too large. So I use both 350 kilometers and 150 kilometers, which are more manageable in terms of access when traveling from the cities to the limits of these radii. Ultimately, the results are robust to all of these variations, and I'm not sure that I have time to go through all the tables in detail here, but the results of the main analysis hold in each of these cases. So the tables are here, but I'll just sort of skip through them a little. You can see from the values and significance that they're all in line with the base analysis, and though there is some variation in magnitude, particularly with the distances around cities. So, in conclusion, the main takeaways are that essentially distance matters for trade in the Iron Age Indian Ocean, and specifically wind-augmented distance, implying a sophisticated long-distance trade network that was supported by the unique geographical elements of the region. In a Ricardian sense, distance reduced the comparative advantage of cities within the trade network. But there are also significant nonlinear effects here, right? And sort of lends credibility to an endowment effect as a supplement to the more traditional Ricardian view of trade. Second is that there is a relationship between the functioning of this trade network and development levels of cities around the Indian Ocean. This is related to an export-led effect, where cities with more exports had higher development levels than those that were dependent on imports. But also a significant resource curse effect, with manufacturers and artisan goods being related to higher levels of development than cash crops and plantation products like spice and incense. And finally, there is also the positive evidence for the Pliny effect, where Roman coin and bullion was related to higher levels of development, though the precise mechanism is uncertain. It's not quite clear. And so with that, we come to the end. So thank you. Thank you very much.
Thank you very much, Conrad. Perfect timing. And yeah, while we have already a couple of questions, and by Chris. Let's see if I can unmute you. And then there is Guillaume then also. So let's see if I can, or Mark can help me unmuting Chris Meissner and Guillaume.
Yeah, hello, good morning, good afternoon. Thanks for this really stimulating talk, Conrad. Very interesting. I have one big picture question and a couple of philosophical questions for you. One is recent advances, as you know, by Archilochus and his co-authors. Maybe they're a little bit old-fashioned now, but there's a neat summary statistic which allows you to measure the welfare gains from trade, as you know. And it's pretty simple little metric. It's basically the share of consumption coming from the domestic market, and it has a little elasticity attached to it. I've always wondered whether you could go for it in these ancient periods to kind of ask, what was the welfare gain to trade for these places? You'd have to make some assumptions about, the share of expenditure, expenditure shares on different goods, but people have done that, like Bob Allen has consumption baskets, and now you've got all these luxuries coming in via trade and some non-luxuries. So wondering whether you're interested in that. A couple of philosophical questions. One is the Ricardian model always assumes you buy from the lowest cost supplier, and like that kind of limits your ability to consume multiple varieties of a seemingly similar product. But I guess if you define the products as different, then you can get away with it. But that's kind of a pet peeve, and I don't know what it does to your model, but it's worth considering. And finally, I think at one point you said, quote unquote, humans are the same across time. And well, I'm kind of okay with that, but I've heard, others may not be so inclined, and some people may dispute the level of economic rationality in the past, or at least think that they may the kind of activity humans engage in could be mitigated by cultural and institutional constraints. So you may want to be a little careful with that, but I'm not totally opposed, but just a point. Sorry for being long-winded. Thanks again.
Yeah, no, thank you very much. And yeah, I think the
Conrad, if you're not using your presentation for answering questions, perhaps it would be better if you can stop sharing the screen, and so we can see you. Yeah, that's much better. Yeah.
Yeah, no worries. So in terms of measuring welfare, I think it is something that is interesting in this, and I find it really interesting in the ancient context. And you're right in the sense that the difficulty is making assumptions and estimating that consumption element. And I think broadly, to sort of opine on it a bit. I think broadly it's very feasible. I think the question is in terms of this data, I don't know how feasible that would be, just because of the sort of limitations of the sources and the information about it. But I think it's definitely something that that's sort of worth exploring, and that I'm interested in that sense. Your point about the Ricardian model, yes, that is exactly sort of either the issue or the benefit of the Ricardian model, depending on how you look at it. But I think it's one of these situations where the assumptions fit much better for certain goods rather than other goods. So a lot of the products that are traded in this instance, for example, they tend to be very generic, in the sense that it's they tend to be bulk. I don't really want to call them raw materials, because they're not all raw materials, but they verge on sort of raw material homogeneity type sort of thing. So it's a valid critique, and I think the cultural factors and cultural elements are an important part, and that's sort of, as I mentioned, the Roman thirst for spices and incense. That is a purely cultural thing. There's nothing sort of inherent about the geography or the economy of Rome that made that a particular penchant real. And so I think it's a valid critique, but
Guillaume, you have questions? I think that
Yes.
I muted you. Yeah.
Can you hear me?
Yes.
Yeah. Well, thank you very much for the paper. It's really a fascinating subject and a fascinating treatment, and I have long list of questions which I'm going to restrict myself. So the first one is just some curiosity that the paper is only as good as your source, obviously. So it would be nice to know, why did this thing survive? If it is such non-exciting and just a tried gazetteer. I mean, how did the medieval monk? Why did the medieval monks save this stuff instead of comedy by Aristotle? Just asking the question. Now more about your work. Why is your outcome variable absolute growth rather than relative? Because we usually expect growth to be measured in a relative way, because what's important is how much is the number of sites increased rather than the absolute number. Which brings me also to the question that maybe we would need. I would have loved to have more, and I understand your time is short, but I would have loved to have more descriptive statistic to judge the value of the coefficients, because so they're not elasticities, because I don't think they're elasticities, right? Because you don't have, you have absolute growth as an explained variable. So what's happening there? Another question also, so you've done a lot of work on the seed distances, but for some reason you don't do anything, or I didn't get it. You don't do anything about the hinterland trade distance. Okay, being on the hinterland on a river leading to the port is not the same thing as being on the other side of a mountain range, obviously, and maybe you want to take that into account when you compare your sales. Which is linked to the other question, which is you tell us that this wind modified distance, it's really important to trade. It would be great to have some kind of, I don't know, a horse race regression with great circle by seed distance, and see by how much you improve your explanation of the existing trade networks by actually taking into account the winds. Yeah. That were my questions. Thanks again.
Thank you. And I mean, so why the parapla survived? I mean, I actually don't know. I'm not as well versed in sort of the document research of why it got copied, and sort of where the oldest surviving copy was found, or that sort of thing. I imagine, as with many of these things, it's probably pure luck, and it was probably reused or something like that for something else. But don't take my word on that. I'm not entirely sure. in terms of growth levels, so it's yes, in terms of relative growth, and so the paper does use relative growth in a sense. It uses total numbers, but it's growth on over the existing period. And so it's not converted into, well, I mean, ultimately it's sort of converted into sort of like a percent growth in terms of, because it's logged. But but it's essentially relative to that first cutoff point of 30 BCE. And yeah, I mean, the hinterland trade distance and a horse race with a great circle distance, I mean, those are both good ideas. That does make a lot of sense.
Okay, there are a couple of more questions in the Q&A, but just let me use my prerogative as a moderator and ask you this. I suspect that some of these cities are sort of entrepots, right? So sort of some are way stations over a long route, for example, from the Upper Egypt to the Red Sea and then to the Indian Ocean. So Berenike, for example, on the shore of the Red Sea. I was struck by the wide diversity of goods traded by cities located in the Horn of Africa, and also the large number of trading cities. So it looks like these are, or for example, Musa in Arabia, or Varigazza, which is Baruch in Gujarat in India. So 64 goods are traded with 15 partner cities. So it looks like these are entrepots. So I wonder if first question, is this correct? So do you have any historical narrative or evidence that these were entrepots, where merchants met, collected goods produced elsewhere, and then moved goods around the network? If this is correct, the second question is, to what extent this extensive margin you are using as a dependent variable, so the variety of goods traded, is capturing this reality. So the variety of goods traded does not depend very much on endowment or access to technology, but rather it depends, let's say, on the logistic of the transport network which is used. And so and if this is extensive margin capture, this to what extent the gravity model is suitable to explore this dynamic, because we don't really know the ultimate origin and the ultimate destination. It looks like there is a lot of transit trade there, and so the question is to what extent this might be confounding the results, and ultimately whether the gravity is the appropriate framework for exploring this.
Yeah, no, so that's a fair question, because it's difficult when you know, essentially the data depth is so limited, because it's sort of, you know, textual source sort of thing. In terms of whether they're entrepos, I think it's maybe not, you know, the most satisfactory answer, but it's a bit of yes and no. There are a couple cities that are very clearly entrepos. I mean, the ones in Egypt are obvious, right? Because they're the main export centers for Rome, and so those are actually excluded from the gravity analysis for that reason, just because there's so much going in and so much going out. The other ones are, I mean, I guess the best way to describe them would be as regional entrepos, in the sense that, you know, they are either the ruling city or the major city of their hinterland. And so it's very much a sort of core periphery. I don't want to say, you know, city-state sort of idea, because they weren't all sort of city-states. There's some sort of, there's some dynamics there. But they are, I think they can be best described in as cities where goods from the surrounding countryside came together and were exported or imported and sort of within that confined range. And so if we view the cities not purely as cities, right, and sort of with the as it does in the development analysis a bit, but as focal points for hinterlands, then I think it's still very sort of operable in terms of a gravity model, because again, I don't want to call them countries because that's sort of a misnomer, right? But it sort of fits that idea that they are the economic unit that the city represents is the city, but also its hinterland, and that's where the goods in that come from.
Okay, there is a technical question by Kerem Kosa, but before this, Peter Sola has a question. Peter, do you want to ask your question directly, or do you want me to read it? To Conrad?
Go ahead and read it.
Okay, the question is, are there edge effects in that your traveler only went so far? The edges, distances to other ports are likely to be long, hence diversity and presumed development low. But these places may be trading other goods with ports even farther away, with the diversity of their trade being underestimated in this case.
Yes, so there is a risk of that, and it's actually more than a risk. It is a true effect. So there's, I guess it from a historical point of view, it depends on whether you believe that he actually went all these places, but that's sort of immaterial, because the point is that there are at least two areas that he points out in the Periplus. One is I believe it's called Thine in the text, and the other is Chryse, something like that. And these two areas are contentious about sort of where they actually are, and it's believed, I guess, sort of the consensus, but not really a consensus, is that they refer to China and Malaysia respectively. And so those areas are within the network because they're mentioned within the text, but they're not included in the analysis because one, it's uncertain of where they are, and two, they are a little too distant to have functional elements. I guess the sort of anecdotal evidence for them still fitting within the system is that each of those cities only traded one good into the system. And so, from a bit of sort of a non-empirical eyeballing of it, they're pretty low on the list, on the varieties of goods traded, and they're quite far away. So they sort of, you can make the argument that they sort of match that way. But I mean, empirically speaking, it is a risk, and unfortunately, it is a fact that there's probably also a fair amount of trade that's not mentioned in the Periplus at all, because as I said, there's a lot of sort of near city trade and local trade that wouldn't be picked up and would be part of the wider system, and so that is a bias in the results. We have one last question, which and 2 minutes just left. Kerem Kosa, do you want to ask this question directly?
Yes. So actually, one question and one quick comment that I wrote. The question is it possible to verify that some of the resources could, in fact, indeed originate from the places, in the sense that they could be intermediating, right? Like, say, frankincense or spices could be coming from Indonesia. It's mentioned that this city in India is shipping it out to the Roman system. Unfortunately, the Food and Agricultural Organization website data that we use for crops is not useful for that. It's more particular products, so you would have to use some qualitative information for that. And second, it's the endowment effect. I see what you mean, but in some sense, you can bring it into the Ricardian-Eaton-Kortum framework by having covariances of productivity draws that are somewhat related with distance. There are some modern applications of this idea by Natalia Ramondo, trade with correlation. So it would kind of, it could be confusing if people do not hear the exact mechanism you have in mind. But I do find a similar low trade in short distances, more trade in intermediate distances, and in long distances trade costs dominate a similar inverse U-shaped pattern in another data set that I'm looking. So I'm really happy to see that it's validated, this idea in a national trade context as well. Thanks, fantastic work.
Thank you. Well, happy to validate. And I mean,
30 seconds for your last answer.
30 seconds. Okay. So it would in theory be possible to validate. The problem is the textual description of the different goods is probably not precise enough in order to verify actual varieties. Because if you could do that, then you could also do quality based on sort of, cinnamon is better if it's grown in place A than in place B. And so because you lack that element, it would be hard to verify exactly, what type of cinnamon it is or things like that.
Okay, we are at the end of our first hour. We will stop the main part of the seminar now. Let me just announce you that we will reconvene in 2 weeks' time on April 5th. The seminar the speaker will be Pilar Nogués Marco from University of Geneva, and she will be presenting a paper on trading balances of silver arbitrage, Anglo-Asian bullion flows in the early modern period, 1664, 1811. Thank you, everybody, for attending the seminar today, and we hope to see you in 2 weeks. And then we will, I think that's the end, and we will have 15 minutes for more informal discussion after the end. Okay, so I don't know whether we stopped recording or not, but yeah, I think that Nathan wants to ask something. Nathan.
Oh, thank you, Conrad, for a really exciting paper, and actually it's a very nice introduction to the paper we're going to have a couple of weeks from now from Pilar, who's going to look at the same bullion flows, but 1,000 years later or so. I guess it's a persistent chronic thing that historians have documented, this one-way bullion flows to the east from the west. So that's kind of it's a nice setup for the paper in a couple of weeks. In terms of these, I mean, I have one comment and one suggestion. So in terms of these gravity equations, so I think it has been raised here in a couple of interventions already that the Pliny data set, as we might call it, might not be representative or could be selective in many ways, and there are all these omitted destinations and goods or whatever that could have taken place in reality. So again, one comment and one maybe suggestion. So first of all, in those gravity equations, or even in presenting the data in your paper, it would be useful to have some kind of descriptive statistics on the kind of the distribution of the trade between the extreme nodes, say the Horn of Africa and India, as opposed to those going to the Entrepot and back and forth. I mean, so obviously the data includes everything, but just this is a picture for the reader, how much of Pliny's data is capturing sort of between places where not connected to the Roman Empire, let's put it directly, but rather the nodes rather than going through the centers or the entrepots or whatever you want to call them. Related to that is, can you, in those gravity equations, in the same way we do the modern gravity equations, do an interaction or a dummy or something with those cities that were historically, 300 years later, occupied or controlled by the Greek, by the Macedonian Empire and so forth. So they have some kind of a cultural or something, like in these models, we have like language or whatever that reduces trade costs in some sense. And so adding this kind of, coding the cities that were under Greek Hellenistic influence early on could be interesting, whether they have a higher representative sort of, for other things equal, higher propensity to trade. And finally, the suggestion is, again, since we're dealing with a lot of missing nodes, missing observation, there is this paper by Helpman, Melitz, and Rubinstein that critiques these gravity equations from the econometric point of view and offers some suggestions in dealing with these zeros and missing nodes and whatever, in a way that corrects some of the potential biases when these things are missing. So there's just a suggestion to look at that if you haven't looked at that, to look at that paper. I think it's at a QG or something from 2010 or 2011 or something. Yeah, thanks.
Cool. Yeah, I mean, in terms of sort of cultural stuff, I guess there's sort of two elements to it, right? Because the first is sort of is there a cultural bias within the cities themselves, and so that's sort of captured with sort of, I guess, city-specific fixed effects in that sense. But I think that's an interesting point about sort of it's almost like it's almost sort of analogous to colonial legacy and sort of modern gravity models, right? Like if both cities were within Alexander's empire, are they more likely to trade or something like that? So I mean, that's an interesting idea.
Alejandra.
Okay. Thank you, Stefano, and thank you very much, Conrad. I guess you're hearing me well?
Yes.
Okay, good. I'm very sorry, I just joined the presentation while you were presenting your data, because I'm interested in sort of intra-Indian Ocean trade a millennium later. I was wondering if you have seen or if anything that you can trace to the second, not best, but most often or most common good. Yeah, so far you're talking about bilateral, and I assume that it is a Ricardian restriction. But you talk about diversity. Now, I was wondering about the effects on bullion, because on the bullion trade, yeah, because you talk about developmental effects in the importers, but you didn't mention anything on the exporter. I mean, you talk about the resource curves, but you didn't mention anything about the possible Dutch disease. So I wondered if you have any information that could allow you to do not just good by good, but good and the second good. I know you don't have quantities or values and so on, but if you trade, I mean, also because there is a very different ratio between value and volume. Okay, so if trading with bullion could, improve the relative price of the import or the export of the second commodity or the second good that goes into that ship or into that journey. Because from the presentation, I was wondering what would be the effect, or if there is any effect on trading with bullion, assuming that this is a bilateral trade, which I have serious doubts, but I've seen this 1,000 years later. And also if in the period of time that you have looked at, if you look at sort of the sectorial composition of this trade, there doesn't seem to be any specialization on trading particularly. And if there is such a prime commodity as bullion, I was wondering what are the effects of trading with that for the second best or the second most often commodity, and for whatever sectoral impact in trading precisely. But thank you very much. It was very, very, very nice presentation. A good job.
Just to add to Alejandra's comment, it looks like trading bullion or plateware is quite rare. There are just a couple of cities exporting and 2 cities importing. So it looks like it is a very special form of trade. So if perhaps you can give us more details on that.
Yeah. So that's what I was going to sort of bring up. It is very, so I mean, historically this is probably not the case entirely, but if we take the periplus as representative of trade in the Indian Ocean, and I mean we can have disagreements about that and all that, but that's fine. But essentially, bullion and coin was primarily an export from Rome into the system. and so there was very little trade of it sort of within the system outside of Rome. Part of that, and now I'm possibly veering out of my specialty, but part of that is possibly related to a lack of silver within the system, which would sort of link to the liquidity effects. But particularly in the attested trade in the Periplus, it's mostly, I don't want to say entirely because I'm not entirely sure. I can't remember off the bat, but it's mostly a situation of the author of the Periplus saying that these areas will import currency for the products that they sell. And so that's primarily the effect. And so that's why the focus of sort of the Boolean effect is on that import element, because the only sort of export element is or the only sort of major export element is Rome itself. And so
okay. Thank you.
Conrad, there is an extra comment by Peter related to his question about the edge effects. He says, a way to deal with the edge effects would be to do the estimates by varying the edges to see whether the effect is significant.
That's a good point.
Yeah. And another question I had is whether you can provide some evidence. So you talk about the suppressing effect of distance on trade. So I wonder to what extent you can provide evidence about the specific basket of goods which is traded over longer distances, because we would expect that only goods with higher values are traded over long distance, right? So I don't know whether you can look at the sort of composition effect of long distance trade and using the information on the composition of basket.
Yeah, that's a good point. I mean, I haven't done that explicitly, but that is definitely something that would be good to add. I mean, anecdotally, I guess, from what I remember from the data, is that there is, I think it's best to characterize that there is bias in the sense that what we would consider maybe higher value, and I mean this is a very fuzzy concept because there aren't really sort of value statements, but what we would consider to be significantly higher value, like maybe teak wood or sandalwood or spices and incense and things like that, they do tend to be traded longer distance, but that at the same time a lot of sort of the lower value and sort of quotidian commodities like grain and fish and basic cloth and that is also traded over long distances. And so it would be interesting to look at the exact makeup of that, because my prior on it is that you'll probably get a lot of long distance trade in more luxurious commodities, but then you'll get both long distance and short distance in the more staple commodities. And so there may be sort of a semi-separation.
Would you categorize textiles from Indian cities as high value goods?
So
it looks like that's a specific pattern in the trade network, though these cities seems to be the location of quite large manufacturing sectors, and so we know basically that these were highly populated, and so this is a case in which I think your line of reasoning about endowments and access to technology is fitting better than in other cases. So and as where these were textiles, they were exported towards Egypt, or they were reaching out even the Mediterranean, so going all the way up through the desert to the shores of Alexandria or whatever.
Yeah, and it was again sort of anecdotally, Indian cotton cloth was considered one of the best types of cloth in Rome. Yeah.
Alejandra, last question.
Right. Okay, thank you. My initial point about if it would be possible to do like not just the first but the second best commodity can be applied not just to bullion but to spices and so on. You could probably, I guess you have already a series of ranking on what would be the relatively unitary value of you have ranked the commodities, and can you find any effect of either by sending spices or selling spices or bullion or whatever? What would be the composition? A little bit what Stefano was wondering, but organized in a kind of ranking way. Would that be possible with your data?
So it's, I guess, yes, in the sense of sort of rankings related to popularity of the good. I guess.
All right, that could be.
Sort of like in terms of the amount of customers or the amount of sources or whatever of a good. And so I mean that would be the way to do it. And that would probably be the only reliable way to actually get something out of it, because you wouldn't be able to rank it in terms of value or sort of explicit volume, but it could
or
be
demand, or the demand of it or whatever. I just to capture that question I had about bullion, but could be in terms of the very fabulous goods that luxuries could be lowering the relative price of the second one. Just a question. Anyway, thank you.
Okay, thank you. I think that we have to stop now. It was very, very interesting to listen to a presentation on this fascinating project. And thank you to you and all the participants for the very lively discussion. I think that was a lot of fun. Thank you very much.
Thanks very much,
Conrad. Thank you.
Thank you very much, Conrad. Thank you very much, Stefano.
Goodbye.
Bye-bye.